Thank you, and thank you for having me, first of all. Yeah, I have just a couple of slides to introduce a bit the context and explain why I'm referring to this Avengers series. And apologies for whoever does not follow on that. I just put a quick translation of the problem on the corner here. Yeah, the main theme of the presentation will be, okay, I have an end-to-end test suite for my Kubernetes components. I have a software that runs with different components on Kubernetes, and I want to avoid the typical push and pray. And so this is at least the starting point for which I started to evaluate Dagger in this context. Again, I'm working at the National Institute for Nuclear Physics in Italy. And before going ahead, just let me start with a comment that for now you should just ignore, but it's just to demonstrate that we are doing things live. So I'm starting this call. It will take some minutes. So for the sake of time, I'm starting this right now, and we will come back later once I introduce the context. Okay, so this is starting, I think, so we can go back to the presentation and maybe going full screen. All right. So the context. There are three main players here. The first one is a European project that aims to construct an interdisciplinary digital twin engine. Means that you need most of the resources you can get from HPC centers. In this case, it's a European project, so from Euro HPC centers and from any providers that is participating into the project. We are talking of hundreds, thousands of GPUs in these centers, so quite a lot. Also, same apply to national projects like the ICSC, that is the Center for Research on HPC, Big Data, and Quantum Computing in Italy. So the two players, the InterTwin and ICSC, in which INFN is working, have in common two main features. The first one is that you need access to a lot of GPUs. The most you can get, the better it is. But on the other side, there is a kind of a constraint in which comes the presentation of today. So the tool that we are going to test using Dagger. So we have different science domain that, fortunately enough, are converging toward using Kubernetes frameworks. So this is fine with us. What is not fine with us is that these GPUs in the HPC centers are usually not running on Kubernetes, so are served via batch systems, because this is how science worked so far, and that's for many other reasons. So what we needed at this point is to match the 0.2 with the 0.3 with what we call virtual nodes. And virtual node, again, in a few sentences, just allow me to introduce what we are talking about. It's a black box that you put between the user request to run a pod to the remote resources. So you translate this request in a job into a supercomputer to run your container. And all of this should be as seamless as possible. So you want to streamline somehow the creation of virtual node on Kubernetes. And the tool that we are going to test is Interlink, and I left the reference here. I'll also share the link to the presentation later if you're curious about it. So these components, this tool is composed by two main components. The first one is a Cloud Native Foundation one, that is the virtual kubelet. So it's a technology that is there to create the abstraction from the Kubernetes perspective. So you submit to a node that is not a physical node, but it's a virtual one. So it's able to ask for particular custom logic, a remote server. The remote server is the Interlink server. So this is a pluggable REST server. You should imagine like this, that allow to plug your logic. Means this container should run in a Slurm job with this configuration, this and that. Yeah, so this is the situation, and these two guys can talk either via Unix sockets or HTTP REST. That's up to the topology that you have in mind. Well, yeah, I know it's pretty fast, but it's not the core concept of the presentation. The core message that I want to share is, okay, we are pretty happy with mostly anything of this approach. We started really in since few months, and it's going pretty good. We had a presentation at the AI Day at KubeCon, and we did some scale tests. We started having early adopters, and here start the problems. I'd say the problem that we want to solve with the Dagger integration. So yeah, let's see now what is actually the problem. The problem is that in this particular scenario where you have a custom component of a Kubernetes cluster, you have something that should run somewhere else that should talk to this component that is running inside Kubernetes, things start to move too much, and it's easy to start losing the control on the development, because I changed something that looks harmless, but for some other providers it's crucial. So it starts to be very quickly a problem that we want to address. And also, we want somehow to get from the provider, so from an HPC center that is using its own plugin, I want to guarantee that each other release of the software won't break the plugin that is in place at the current time. So yeah, I suppose it's not so weird as a scenario. I think it's well in line with many other cases. And what triggered our curiosity in this context was, well, before the module, it was the discussion in Discord channel about running a Kubernetes cluster inside Dagger runtime. But then definitely the module that was shown by Marcos last time definitely triggered pushed our interest in it. And yeah, we work into prototyping a first approach for our use case. And this is why today I'm presenting them, actually. So what this means? Yeah, that from our perspective, we have all the tools in place for the particular case studies. So we are able to submit a pod that is running instead on a Slurm supercomputer, but we need stability as much as we can get. And so we need one last stone. And I think we started to demonstrate that Dagger can be one of that. So the solution I'm going to showcase is a module that starts from the K3S module provided in the Daggerverse and implement 3 main additional tasks. The first one, we set up a K3S cluster plus a local registry. We want user to be able to rebuild any binary of our software without the need to internet connection. So we now need to push and pull continuously images from a remote cluster. So we want a local registry, and this is really awesome, I would say. So the task 1 is the initiation, if you want. And the task 2 is the installation process. So we have a call that will be able to instantiate the different components in would say in a flexible manner. I will come to this later. And eventually, the task 3 is the exit strategy. So you want either to do a test or to instantiate a test environment. So run a terminal or get access to the Kubernetes cluster from the host. So these are the 3 tasks that we implemented so far and are summarized here. So we have a new call that instantiated the K3S. We have a build that build images and push to the local registry. And then we have the load one. So you start instantiating your components. And at the end, you have a test or run command. So as I mentioned before, we started like, okay, this is a cool tool for end-to-end. What I find interesting is that we are also starting to think that it might be also a good get starting package for our user or newcomers. So you give some command that bring up everything they need to test our environment. So it might be more than an end-to-end tool, an end-to-end test suite, let's say. So yeah, these are the questions you want to answer, but let's move on. And I think if there are no questions regarding the concepts, I will move to the demo. So first of all, let me ask here. And okay, the module, it's very basic. Is, as any good physicist, is not well documented yet. But I suppose that if we get convinced that is the way, we will get better. So we produce anyhow an introduction of the usage with a basic command in our documentation. So it's not perfect, but it's a good starting point, I would say. So the modules here, we have different code, but I rather go through the code to show you what is happening in here. So we start with creating, well, these are the templates because we want to select the image from the local registry with the name that is indicated by the user. And then our module interlink is this one. So we need a registry. We pass the manifest for the installation in a directory. We have kubectl, kubeapis, and kubeconfig that we can either automatically instantiate through the K3s module, or we can use, the plan is to use also an already existing Kubernetes cluster. So this kind of flexibility is quite the key in our scenario. And okay, so we instantiate a new interlink instance, and the core start here. So oh, sorry. So you see again the flexibility that I mentioned before. We start, we pass, we can pass a set of optional configuration depending on the scenario. If we are running local registry instantiated from the Docker, from the Dagger call, this will be filled automatically. Otherwise, we can pass a service from the command line, and this will be take immediately. So we can even use a registry that is running outside the Dagger runtime. So then we have a plugin endpoint. This means that the final plugin that is responsible to talk to the Slurm cluster in this demo will talk to a Docker daemon that is remote with from the perspective of the Dagger runtime, will be executed outside Dagger. It can be also instantiated inside, but for the sake of simulating a real scenario, I will put this plugin running outside Dagger runtime. And then there is the core instantiation of the K3s cluster. This is the module from Marcos that showed last time. So we instantiate the module with the configuration, say, okay, look, you need to mount some directory and you want to also have the capability to talk to the local registry. And also to the plugin service that we run outside the Dagger. So this service here, this line here, oops. This line here means that you have the binding to the plugin running. We start the service, we store some variables. Some of these can be broken. I'll talk about this in the chat later, but for my fault, mainly. But yeah, they're not fundamental, this step. Okay, scrolling down, there is the templating for the manifest. So we update the image name with the correct ones. And we set up a kubectl container. So this is the one responsible to interact with the cluster. So we mount here, we mount the file from the kube configuration, and down here instead you can see that we are mounting the manifest. So the YAML that are responsible to instantiate all our components. And okay. Then what else? We have, okay, we go ahead and we instantiate here. This is the part we instantiate all the required components. The other call is build images, as I told you before. So build images is the one responsible here to bring up the registry and build our binaries, put this into images, and push the tar of these images into the local registry. So I didn't find any easier way to do that. Maybe someone can correct me if I'm wrong, but yeah, it's not a problem from my perspective. You should also just do an extra step when you build an image. You should pass from the tar and then do the push to the local registry. Not really a showstopper, I'd say. And then we have our exit strategies, if you wish. So we have a kube call that is only instantiating the Kubernetes cluster and return the reference to a service. We have a run that is actually doing all the preparation steps and log you into a container that is ready to run tests interactively. And then there is the test call that do the same as run, but also here in the last line, there is the PyTest that we put in place. So PyTest is the test suite where we test different kind of pod and we test the responses. So we test the whole chain and we understand if at any stage, plugin, interlink, or the virtual kubelet, there are any issues. So we collect a series of default pod that should work. We want to be sure that that kind of pods are working. Okay, so that's all from the code perspective. There are few calls and that we are going to see working in practice. So what I just started before is a command that looked like this. Let me just recover. So a Dagger call, a Dagger call with a certain name that is the parameter to identify your module, your instantiated modules. So your cache will get the name that you already dictated here. Then you build images from our source folder. You see here I'm in interlink/CI, the official repository. So we want to mount everything from the interlink to be able to build our binaries. It's not optimal. We are working through that, but yeah, it's good enough at the moment. Then we have the new interlink call that we saw before, and we pass the plugin endpoint that we run on the localhost. I show you in a second, and the link to the manifest. So the dot manifest, if I show you here, ls manifest, in here I have all the customization that we want to use to instantiate the services. And so with this command, we can see also, I think, from the Dagger Cloud. Come on. Okay. So from the Dagger Cloud, first of all, let me show you why this is so intriguing for us. This is my local history of failures running tests. And this is the one from the official GitHub Actions. And you see that the story is quite nice. There are some flaky errors, but yeah, when things get complicated, you see it can happen. But well, we couldn't achieve this before having Dagger and telling us that, yeah, this is something very cool. Okay, so I wanted just to show you the different steps. So we started from interlink, we instantiated interlink, and we did the build images. So all the images are built and pushed to the remote registry. So you see here, we're pushing to the remote registry. And then we instantiate our components. So we bring up, we bring up here the K3S server, and yeah, we have everything running smoothly with the server start. and then eventually we do all the installation step of our container, and we end up at the end of the story installing our manifest, our customization here at the end. And the test part is just building the container for the test and then doing PyTest our clone. And the output is quite satisfying. As you can see, all the basic tests that we have in place are passing. So this is a very cool scenario for our needs. One very cool thing, in addition to this, okay, just to tell you that I'm not cheating, this is the daemon for the plugin that is running. So the one responsible to run custom containers based on your pod requests. It's receiving a request and it's running, you see. So everything is working. The cool thing I tell you before is that we want to also provide this to users and telling them this exact thing. Let me go back to the documentation. The dream is, okay, you can test the whole chain with a single command. That's cool. But it's not cool like, okay, you have everything set up. So you have a Kubernetes cluster with everything installed. You can bring it up and start working locally with that. So you can have your repository, you can test different components, you can push different images to the local registry, and you can start iterate and testing in this way. And with this approach, we need just few changes. Exactly, we need just to change the exit. So we need to call kube and up, bringing up the service. And what is happening is just here. So the service is up. I started this before. Sorry for that, but it is taking too much time for a demo. And you see, the command is exactly the same. I have just done kube up. So what you can do at this point is the following. You go here, we clear the screen, and we can get the kubeconfig that we need. So my local test should be this one. Yeah. We got the kubeconfig. It will retrieve the kubeconfig from the running service. And all right, hopefully it should take very few time. Okay, you see it's retrieving from the cache the K3S YAML. Okay, true, it's copied. I can export, oops. I can export kubeconfig and say, okay, get pod, and you have a functioning, working service that you can run and instantiate all your manifest and so on and so forth. So yeah, there is a wish list, of course. I don't want to go too much deep into this, but of course we want users to be able to deploy things on their own Kubernetes cluster. Should be trivial, but not implemented yet. And we want to provide also additional command for developing environment for different components, for all the different components. Yeah, so this is the situation and what I wanted to share. Of course, there are a lot. At the moment, the tests are taking kind of 10 minutes. I think we can drop it dramatically if we start using caching mechanism quite wisely. But yeah, that's a working point. I leave you here some references, and I also take the occasion to share that we are going deeper into this. I'm playing live, trying to learn as much as possible next Tuesday for in this live. This is also the contacts for the community if you are interested in the tool itself. Yeah, thank you. That's all from me.